welcome back. We're going to continue talking about data distributions. Today we're going to talk about frequency charts and histograms. So just going back, and we're going to talk a little bit about stem and leaf plots. Going back, stem and leaf plots, okay? So we have Natalie and Rosie. Scores for 10 games of bowling are given below. We want to use the data to make a stem and leaf plot. Now remember, when we're looking at a stem and leaf plot, and this is a double stem and leaf plot, so if we just pretend we're looking at just Rosie's side. Remember, in the stem part, we write the tens place, okay, or anything above that. Okay, and in the leaf part, we only write the ones place. So in the name part, on both sides, will only be the ones place of the number. Okay, so the last number in the number. This part, which is our center in a double stem and leaf plot, or the left-hand side in a regular stem and leaf plot, is like the tens, hundreds place numbers. Okay, so I'm going to go ahead and get rid of all this jibber jabber that I did all over the place. Okay, so I'm looking at these numbers. Okay, so we have Natalie has 137, 149, 167, 134, so on and so forth, right? And Rosie 129, 138, and so on and so forth till we get all the way up to 130, right? So what I did is I just looked through the data and I said, okay, what's my biggest number and my smallest number in both sets of data? And I've highlighted that. So Natalie is going from somewhere to 121 to 168. And Rosie's going from 128 to some 160. Now what I'm going to do is, I really care about these front numbers. Okay, so we have 12 to 16. Okay, so that's our tens place, or our hundreds as well, right? It's just everything but the ones place. So what I'm going to do is, I know I need to go from 12 to 16 in my stem part. So I'm going to have a 12, a 13, a 14, a 15, a 16. Okay? Now what we're going to do is, I'm going to go ahead and erase this. It's being a little stinker. Okay, what I'm going to do is, I'm going to take each number for Natalie, so we're going to have 137. So 137 means a 1, 3, and then a 7 afterwards, and I'll have a comma. Okay, 149, so I'm going to put a 9 here. 167, so I'm going to put a 7 in the 16. 134, there's going to be a 4 here. 121, there's going to be a 1 here. 127, there'll be a 7. 143, okay, it's going to have a 3 after the 14. Notice I'm putting a comma between each number I'm putting in. 123 is a 3 here. 168 is an 8 here. And 162, what I'm going to do is I'm actually going to move this over. Okay, because we like the numbers in order. Okay, so I'm going to put that 2 in front just so it's in order. And then I'm going to look through, and I notice for 12, I have a 3 and a 7, so I'm just going to flip-flop those so they're in the right order. Same with the 4 and the 7, and the 3 and the 9. Now you can do this as you're writing, I just didn't do it in the moment. Okay, I'll probably do it for the next one. And there was nothing with a 150 score, okay? Now I don't write a 0 there, because otherwise it looks like I have a score of 150. I just leave it blank, okay? So even if we don't have a number for Natalie, and I did these on the wrong side, I'm seeing, I apologize. We're going to flip-flop these names. This is going to be Natalie. So you should always read your chart. This is going to be Rosie, so I apologize. You can either flip-flop them in the columns or just flip-flop the names like I did. Okay, so even if Rosie doesn't have a 150, we're still going to write this 15 here because we should have continuous data going on, okay? We shouldn't just like skip a number, okay? Because maybe we'll add another score later. Okay, so there's nothing in 150 for Natalie. Now we're going to do Rosie, and I'll do a different color for Rosie. So again, what I'm going to do is I'm going to do 129, and what I might do is I just might write this 9 a little bit later, just so I have room in case I need to fill that in. 138, and 8's a little bit bigger, so we're going to go that way. 141, that's probably going to be pretty close. 124 is 4. Now you could go about and find all these numbers in order if you'd like. I just like being able to cross them off so that way I know I'm not messing something up. 160 is going to be a 0. 149 is going to have a 9 here. 145, 128, and 130. So I'm going to go ahead and move my 8 and 9 over here. Okay, and my little comma didn't make it. Okay, notice that as we go outwards, the numbers get bigger. Okay, so we kind of flipped it around here on Rosie's side. Okay, and notice again, both of the girls did not have a score within the 150 range, so there were no numbers there. I'm still going to leave that 15 inside my stem and leaf plot because we do not want to skip any numbers in the stem and leaf plot. Now let's say we add a score to Natalie, and she got a 68. She did really bad, not a 6,8, a 68. Okay, now you don't have to actually do this in your notes, but I'm just going to go ahead and move all this stuff down. If I had a 68, I would have a 6 here, and I would have all my numbers in between, and then I would write an 8, right? And if I had a 55, it would be a 5 and then a 5. If you had a score of 9, you did really bad, you only knocked one pin down for every roll, you'd have a 0 in this place, and then a 9 here, okay? So that's kind of a review. We learned this in Math 7, just to kind of remind you of what a stem and leaf plot is. This is a double stem and leaf plot. Okay, or a back-to-back stem and leaf plot. Sometimes they're called different names. Okay, next thing we're going to do, and I'll leave that up so you can pause it and catch up if you need to. We're going to make a frequency table. Now, I've kind of cheated a little bit and written some of the numbers just so our video isn't so long. Okay, so a frequency table is where you take the scores and then you tally up how many are happening. So frequency is how often is something happening. So the final score for each golfer in a tournament is given below. Use the data to make a frequency table with intervals. So we're making intervals, and in order to make an interval, I'm going to take my highest number minus my lowest number. So I went ahead before the notes, and I found my lowest number to be 68 and my highest to be 82. So 82 minus 68. And if I do 82 minus 68, that's 14. Now that means there's 14 numbers to get from 82 to 68. But that doesn't include the number 82. So I'm going to add 1 to the 14. So always add 1 extra when you're trying to find intervals after you've subtracted. Okay? And if you count 68, 69, 70, and so on and so forth, and you actually physically count all those numbers, there's actually 15 numbers in that range. But it takes us 14 numbers to get from 68 to 82, which is why you get 14. So please, please, please remember we're going to tack and add on 1 when we're trying to find an interval. Okay. Now in this table I was given 5 sections, so I'm going to divide this into 5 intervals. So I want to figure out how many numbers are going to be in each interval. Now depending on your range, this is a very small range of 15. Okay. So 3 numbers per box is really nice. So 5 boxes is great. If we had 21 numbers, I might divide it into 7 boxes so I had 3 numbers in each. Probably 3 to 5 numbers in each interval is good, okay? So 15 divided by 3, or divided by 5, I'm sorry, is 3 numbers. So what I'm going to do is I'm going to start at my smallest number here, okay? And so I started at 68, and I'm going to have 3 numbers in that range, so 68, 69, and 70. I'm not adding 3 to 68, I'm saying there are 3 numbers within that range. And then the next one would be 71. And then I have 3 numbers, so 71, 72, 73. Then 74, 75, 76. 77, 79, 77, 78, 79, sorry. And then 80, 81, 82. What's nice is we have our lowest number to our highest number. Now, sometimes that doesn't work out perfectly because maybe you get 13 as your number and there's no way to distribute it evenly. So if you need to go a little bit lower or a little bit higher on your numbers, that is totally fine. So like if for some reason my range had started at 67 and gone to 83, that would work as long as all of your intervals are even, okay? So you can add a couple numbers if you need to, just to make this range number here that we created a pretty number to divide it into whatever number of intervals you want. 5 is usually a nice number of intervals. So what I'm going to do here is I'm going to find how many numbers I have between 68 and 70. So there is 168, there's 170, 2 70s, and there's no 69. So there's 3 numbers in that interval. So what I'm going to do is I'm going to put the number 3. And you could tally it if you want, but it's easier to just be like, oh, there's a number 3. And if I count 71 to 73, there's a 71. I'm going to do it in a different color here. There's a 71, there's a 72, there's a 71, a 72, and there's no 73s. So there's 4 numbers to go with, okay? And I would do the same thing for 74 to 76, and there are 6 numbers between there. 77 to 79, there's 2 numbers there. And 80 to 82, there is one number there. Okay. So this is my frequency table. This is how often these numbers are occurring. So there are 3 numbers here, 4 numbers here, 6, 2, and 1. Okay. And that's what we want. We don't want a ton of numbers. We don't want like 15 in this one and 0 in this one. Sometimes that'll happen, but very rarely. We like to see kind of a spread of data going on here. So there's a handful of numbers in each one, and that's a good showing of what's happening with our data. Okay. I feel like there was one more thing I wanted to tell you, and now I forgot. We'll come back to it if we need to. Oh, this is what I wanted to do. Make sure you count these numbers. So 4 plus 3 is 7, plus 3 is 10, so 16 numbers. And if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total numbers. So I just want to make sure in my frequency table, this many numbers is the same as this many numbers. Okay? All right, now taking this data, we're going to make a histogram. Okay? Now the important things about histogram is we have continuous data here. So we're going from 68 to 70, 71 to 73. There's no stops, right? Like these numbers just keep going like they normally would, okay? It's not like where we have like green marbles and blue marbles and we're trying to calculate that out. So what I'm going to do is I'm going to start my range. Now I'm going to draw my little squiggle here to show I'm not starting at 1, okay? But I am in fact going to count just by yeah, we'll just go 68, 71, 74, 77, and 80. Okay? So we're going all the way up to that number. Since it's all whole numbers, we can do it this way. And then my y-axis is going to be how many times it appeared, right? So we have from 1 to 6. So I'm just going to count by ones here. 1, 2, 3, 4, 5, 6, and try and make those even. Okay? So then I'm going to draw a bar for 3 from 68 to 70. Now really that goes up to 71 because there's no decimals. Okay, so I drew a little bar and you can fill it in if you'd like. Maybe we'll draw a different color bar for the next one. We're going to go up to 4, and again these bars are going to touch because it's continuous data, right? We didn't skip any numbers. We can fill that in if we'd like. And we try and make these bars as even as possible. 74 to 76 is going to have 6. Okay, and my drawing is not perfect and yours does not have to be perfect. And then 77 to 79 is going to have 2 here. Okay, and I made an oops, I should have had an 82 over here. So I'm just going to pop my graph over a little bit. And they only have 1. Okay, so this is the histogram. So histograms are different from bar graphs because the bars actually touch here, right? Because there's continuous data, there's no jumps. Now some of you it's going to bother because we didn't actually go to 70 here, but because there's no decimals, we're going up to 71 but not over 71. So that's why these intervals work even though they're not the exact same intervals here. So all I did was use this first number, since it's continuous data, as my graph so I can have my histogram bars touching. Okay? Now, the next part is we're going to make a cumulative frequency table. So we use the same information as the last problem. So these were the golf scores and how many people we had. So a cumulative frequency is this first row is going to be the same. We have 3 numbers so far. The next one you're going to add 3 plus 4 to be 7 numbers. Okay? And then we go over. And then 7 plus 6 is 13 numbers. And then 13 plus 2 is 15 numbers. And then 15 plus 1 is 16 numbers. Okay? So again, all we did was our first one goes over. And then 3 plus 4 is 7. 7 plus 6 is 13. 13 plus 2 is 15. 15 plus 1 is 16. So a cumulative frequency table can really help you keep track, and this final number should be the total number of numbers we have overall, okay? Just like what we checked in our previous example, okay? So just one more time, the 3 comes over automatically, then add 3 plus 4 is 7, 7 plus 6 is 13, 13 plus 2 is 15, and 15 plus 1 is 16. Go ahead and try that homework, and we'll